Welcome to this course on digital circuits. So, today any system that we look into, the electronic systems, so you can broadly classify them into two categories, the analog systems and digital systems. However, truly speaking, what you get is a mix of the two. So, you get some mixed systems that has got a part as analog and part as digital. So, if you look into the nature, then the signals that you are getting are analog in their characteristic. So, you get some continuous time signals, the like some voltage values or some say temperature or say pressure or some signal quantity. So, they are all analog in nature, but the analog signal processing has got difficulties because of various reasons, like transferring those signals is a problem. It comes to some noise and all. So, what has happened is another style of processing has become more popular, and that is the digital style. So, where we represent the analog information in the form of their digital values and then do processing of them. So, this helps in designing the circuits in a much better fashion, which are which has got much better fault tolerance, error which has got much better tolerance to errors and noise and all that can affect this system, the electronic systems. So, in case of these digital circuits, so the most important thing that we should talk about is how can we represent this digital information in my system, and how can I process the system, how can I process all those information. So, storage is by means of some memory elements, which are say DRAM or SRAM like that. So, they are storing individual digital information as bits, and their processing is by means of some logic elements. These logic elements can be logic gates, or it may be some flip flops, which are basically doing some sequential processing on the input data stream. So, this digital processing and digital storage, so this has led to a the discipline of this digital circuit design. So, this digital circuit design helps us in realizing many of these real world problems in terms of digital systems, and that makes the system much more robust, much more prone to much more capable of handling these errors that can occur in the transmission and processing. Now, in this particular course, what we will do is we will be starting with this representation of this information that we get from the analog world into the form of digital. For that purpose, so we will be talking about the converters, like the analog to digital converters to convert these analog values into digital values, and on the other hand, for also the digital to analog converter, like when you are going to control some analog quantities. So, you want to put them into analog form after processing them in digital form. So, that digital to analog converter. So, these converters we definitely have to see as interfacing elements between the system, the digital system that we have, and the environment. Next, coming to the digital information storage and processing. So, we will be talking about different memory structures like SRAM, DRAM and all for the storage of information. For the processing part, so we will be talking about the logic gates that are there in digital systems. So, all the processing are essentially done by taking help of switching principles of these circuits. So, this how these logic gates can be utilized for realizing many control applications in terms of some the input signals coming, and according that giving rise to several conditions based on which some decision has to be taken. So, that computation will be done by means of those digital elements, the logic gates. So, different types of logic gates, how to realize them in terms of the different logic families, in the sense that the most important representation of these switches that we have today are in terms of CMOS logic family. So, we will see how these individual logic gates can be represented in the form of CMOS logic. So, so that we can go to different circuit implementation directly. We will also be talking about the other logic elements, like say the flip flops, the registers, the counters, the decoders and multiplexers like that. So, some of them belong to the combinational circuits, some of them belong to the sequential circuits. We will be talking about the design of both the combinational circuits and the sequential circuits. So, after forming this base, where we have got to the understanding got to understand the basic design of these digital systems. So, we will be looking into some microprocessor, which is one of the high end element for doing all these digital computations, and we will be looking into the 8085 microprocessor in particular. So, where we will be seeing like how to do some processing using these digital elements. So, how to program that microprocessor for doing various operations that we need in the different control applications. So, that way this course is going to be helpful for the people who will be trying to learn a first course on digital circuits and microprocessor together, and particularly suitable for this GATE exam syllabus, that in the electronics and electronics and communication engineering, where this digital circuits portion is one part of it, and this course is tailor made for that particular syllabus.